Hello everyone. We have a question from a modulus inequality, but in this question we don't have the modulus on both sides. We just have a modulus on one side and the other side is simply like 3x plus 2. Definitely in this question we would be comparing the questions that have a modulus on both sides and on one side. So what would be the difference for finding the set of values of x? We would be focusing on that. We do have two different methods to solve such kind of question. One is through the algebraic method and the other is through the graph. So first let us focus on and work according to the algebra. The process is very simple. Just go for squaring both sides. After squaring both sides, instead of this modulus sign, simply write the round brackets, and after squaring just use the formula of a minus b whole square and a plus b whole square, and which is equal to a square minus 2ab plus b square, and over here a square plus 2ab plus b square. Now just rearrange them on one side because this is 9x square, this is 4x square, 4 is less than 9. So what I have done, I have moved all these three terms on the other side, and finally after moving them on the other side and arranging them in such a manner that the like terms are written together like x square and x square, x and x and a constant and constant, and after simplifying we have the condition 5x square plus 24x minus 5, and this is greater than 0 because it was over here, so I have written over here greater than 0. The second step is that finding the critical values. Critical values means the values of x on the x-axis, that means on the x-axis y is 0, so use quadratic formula and solve this particular quadratic equation, get the two values of x which are on the x-axis, and based on that we would then decide what will be the set of values. So just use the quadratic formula, and use the values of a as 5, b as positive 24, c as negative 5, place them in the quadratic equation, simplify them and get the two values, the critical values, also called as the x-intercept, which are 1 upon 5 positive, so over here, and negative 5 over here. Because the quadratic equation had a coefficient of x square a positive 5, that means we had a u-shaped graph. So in this particular question we just have a modulus on just one side of the inequality, because if we would have the modulus on both sides of the inequality, then we would have done something else. If we just look at this particular question, in this question we have the modulus on both sides, so definitely after using the same process, getting the two critical values, because we have the modulus on both sides of the inequality, by looking at this inequality sign which was less than 0, then we will decide whether the values are this one or the values are this one. This is less than 0 means negative, definitely negative means the values below the x-axis, and if it is greater than 0 positive, definitely the values which are above. So this would be done if we have a modulus on both sides of the inequality, but the question that we are doing right now does not contain a modulus on both sides of the inequality. So in this question we would not go on with the same process. A slight change would be there, that is, we have three different areas where the answer will lie. Because the critical values are minus 5 and 1 upon 5, as you can see over there we have written minus 5 and 1 upon 5, so we can take any value which is less than minus 5, as I have taken negative 6. We will take any value between minus 5 and 1 upon 5 as we have taken 0, and any value greater than 1 upon 5 like I have taken 1. Just write the question with the given question, and use these value -6, 0 and 1, place them in the given inequality and see what the answers would come. That means if we take x as -6, we have seen that the answer would be 15 is less than -16, which is totally wrong. This is positive. It can never be less than 16. So I have written false over here. If we take x as 0, and in the question I have written, instead of x I have written 0, the condition was 3 is less than 2, again, which is totally wrong. That means, and if we take x greater than x equal to 1 and place it, we can see it is 1 is less than 5. Definitely it is a true condition. That means the solution set will not lie in these two areas. That means -6 and 0 in these areas. The solution will lie in this particular area because it is given a true condition. That means all the values greater than 1 upon 5 will actually be the solution of this particular inequality. So finally we have written the set of values of x are x greater than 1 upon 5. So this is the main difference, that whenever you have a condition where you have the modulus sign on both sides, as we have seen before, we can easily from the graph judge and write the set of values. But if we just have a modulus on one side, then we have to go through this process, take the values on these three areas, any values which lie in these three areas, work on, get the actual condition which definitely states true for that, and that would be the set of values. If we go for graphical method, use the same condition, we know that we have two different linear equation. One is a modulus linear equation and one is a simple linear equation. Just place both of them equal to y because it is a linear equation. Just take any values of x, -0 or positive for both of them, get the required values of y, and after getting the required values of y, just draw the graph. As you can see, I have drawn the graph and used two different colors so that it becomes very easy for us to recognize the area which is the required set of values of x. This red line is basically the graph of y is equals to 3x plus 2. That means this one, this is a red line, and definitely because it doesn't contain some modulus sign, that is why the graph is going below the x-axis. But this is 2x minus 3 with a modulus sign, and we know that the modulus is never negative. It is always positive. The minimum value a modulus could have is 0. That is why we can observe that the graph is touching the x-axis and bouncing back. It is never going below the x-axis because below the x-axis y is negative. After looking at the two graphs, we have observed that the intersection point is just 1, which is 1 upon 5. And definitely over here also the set of values was definitely 1 upon 5. Secondly, the graph, this 2x minus 3, I have drawn the graph of this with a green line and this 3x plus 2 with a red line. If that means this 2x minus 3 over here is representing a green line, and that means green line is less than the red one. Now observe the graph where the green line is less than red line. If we take any value less than 1 upon 5, it is observed that the green line is above red line. When we say the green line is above red line, that means the green is greater than red. And the green is this, the modulus 1 is green, and this is representing green line, and green is greater than this? No, it is less than. According to that, that means any value less than 1 upon 5 is not the solution of the given inequality. But if we take any value greater than 1 upon 5, it is observed that the red line is above the green line. That means the red line is greater than the green line, and red line is 3x plus 2, and this 3x plus 2 according to the question is greater than that, and this states true for the given condition that this is representing the red line and this red is greater than this green one, and definitely any value greater than 1 upon 5 would definitely result in a condition that this red line is greater than the green one, and definitely any value greater than 1 upon 5 would result as the set of values for the given inequality. So make sure if the question contains a modulus on both sides, then simply follow this process, and based on this, from the graph we could easily make the judgment and write the set of values. But if the question contain a modulus on just one side, then please go through this process where take any values in the three region, observe them, check them, where it states true, that would be the required area. Or and secondly, from the graph also it is seen that there was just one point of intersection, and we could observe and write the final set of values.